guys doing? My name is Rodney Bullock Jr. I'm an X-ray tech here at Naval Hospital, Naples.
Hello, my name is Marco Torrico, and I work in radiology.
Hi, my name is Frank Jama. I'm here in Naples, Italy, and I'm an X-ray tech.
Hi, my name is Manuel Bañuelos, or Manny. I'm an X-ray tech to work in Naval Hospital.
Alright, play the movie. How many of you in my audience has ever received an X-ray? For those of you that have received an X-ray, common concern might be radiation exposure. Well, I would like to alleviate that concern by telling you a little about what I do. My name is Sean Fryer, and I've been an X-ray tech for about 2 years now. And I would like to tell you about a study done by the Mayo Clinic in 2010. They discovered that an individual receives more radiation by flying commercially for 4,500 miles. Today I'm going to tell you about 3 aspects of diagnostic X-rays. The first aspect being the origin of X-rays, the second aspect, the physics behind X-rays, and the third aspect being the several uses of diagnostic X-rays today. Does anyone know how X-rays were created? Okay. Well, today I'm going to go over the first aspect, which is the origins of X-rays, and that's going to begin with William Röntgen. William Röntgen discovered X-rays in 1895 and won the Nobel Peace Prize for his discovery in 1901. As a matter of fact, is the first X-ray of his wife's hand. The first medical use of William Röntgen's discovery was by a German doctor, which requested the use of his X-rays for a little boy. The X-ray of the little boy's lower leg revealed evidence of osteosarcoma, or known as bone cancer. The first clinical use of X-rays paved the way into the mainstream. Before I get into how X-rays are used today, I would like to inform you of the physics of X-rays. The second aspect of X-rays is the physics, and that begins with high-speed electrons. High-speed electrons are fired upon a tungsten target. Tungsten is used because of its high atomic number, which tolerates the high temperature impact of electrons with every single X-ray. The interaction between our body and the high-speed electrons occurs at the atomic level. This is a breakdown as to what happens. So high-speed electrons are shot through our body and interact with our electrons, knocking one of the electrons out of orbit on an atomic level, creating a light being emitted. That light is then transferred to the X-ray film, creating the image. This happens millions of times in one X-ray. So now that you know the physics behind it, you can now move on to how it is used today. It was a Barney-style explanation of the physics, but with all the bases covered, without any boring formulas or technicalities. Now that you all know the basics, let's go to how X-rays are used today. The several uses of X-ray today is a third aspect of my speech. I'm going to go over a few of the many uses of X-ray today, and that one being computed axial tomography. The machine is basically 3 or 4 X-ray machines spinning in circles around a patient taking X-rays that appear as slices of the body. It would appear like this. Just thin slices. This is a head CT showing an aneurysm or stroke. The second most common use of diagnostic X-rays today is called fluoroscopy. It's real-time imaging of the human body. It looks just like a regular X-ray, yet in real time, a movie, so to speak. This is mainly used to evaluate the gastrointestinal system and evaluate swallowing difficulties in patients. Gastrointestinal study with fluoroscopy will look something like that. This is your large bowel. Enhanced with contrast under real time. Now that you know a little about x-rays, I hope you have a better understanding. And knowing that diagnostic imaging is improving every day and therefore enabling the earlier earlier diagnosis of today's diseases. Today I just discussed the three aspects of x-rays. First aspect being the origin of x-rays, the second being the physics of x-rays, and the third aspect being the several uses of x-rays today.